There are many, many different sorts of animals that live in the ocean. We often think of the vertebrates, that is, things like sharks and fish. But a huge amount of the ocean animals are what's known as invertebrates. So these are animals without bones. So invertebrates are incredibly varied, from things like corals and sponges, which look almost plant-like because they don't move around and they don't have eyes or tentacles or anything like that, to the really complex, large, intelligent organisms like octopus and squid. And octopus are really, really smart. There's some wonderful examples from captive octopus where they've managed to untie jars to get food, or one particular one, they couldn't understand why the light in its aquarium kept on going out. And so they put up a little video, and what they found was that it would squirt water at the light, it would short, and then when the engineer came to change the light bulb, he would play with the octopus for a little bit. And so all the octopus wanted was some company, and it worked out by shorting out the light bulb, that was the way to get it. So we all know that the oceans are subject to anthropogenic change. So humans are leading to the oceans changing through pollution, through overfishing, and through climatic changes such as global warming. But how does this affect all the different organisms that live in the ocean? So we're probably familiar with coral bleaching, where corals get really stressed and release all the little symbionts, little algae which they need to survive. But climatic changes and anthropogenic changes don't stop there. Through things like overfishing of large predatory fish, this changes the dynamics of how different organisms interact with the water. One of the consequences that's starting to emerge is different sorts of organisms are taking the roles that fish used to occupy. So for example, jellyfish are becoming more and more abundant. So jellyfish are very good at adapting to different sorts of environmental changes. When they reproduce little polyps that sit on the ocean floor, and then they hatch when the environmental conditions are ready. However, if you have some very bad years, it's too cold or too hot, the jellyfish won't hatch, they'll just stay there. Whereas fish, for example, will hatch, and then most of the fish babies will die because the environmental conditions aren't right. The jellyfish will stay and wait. And so say you have a few years where you have really bad environments, when you finally have a good environmental year, you have the same amount of fish, but you have potentially 3, 4, 5 times the amount of jellyfish. And because they're competing with the same food as the baby fish, the poor fish get swamped out and you get a lot more jellyfish. Now this is problematic because they're not eaten by the same things. They're a lot less nutritious, jellyfish, compared to fish. So this is a problem for all the things that rely on the fish for a food source. The jellyfish are kind of taking over the oceans in a way, but they're not being able to provide the nutrients to other organisms, and so you're breaking down the ecosystem dynamics. So octopus and squid and cuttlefish are a group of organisms called cephalopods. Climatic changes are actually really helping the octopus and the cephalopods and their numbers. So the reasons for this aren't really well understood. One possibility is that with the overfishing of large predatory fish like sharks, there's more food available for the large Humboldt squid, for example, as well as octopus. Another idea is that because they have very, very short lifespans, often some squid are just 1 or 2 years, it means that they can reproduce very, very quickly, and so they can adapt to climatic changes much, much faster. Another thing that's happening with cephalopods is they grow relatively fast compared to vertebrates, sometimes eating as much as 30% of their body weight in a single day, which is great for them. They can grow and get big very, very quickly, but what they're doing is then taking away more food from other organisms such as fish, and so that can potentially put the ecosystem out of balance.